Hi. In this video I'm going to talk about the distributive property of multiplication over addition, which is quite a fancy term. Essentially it means a certain way that we can choose the order that we're going to do operations in when we have multiplication and addition. Now my intent here, I'm going to do it all with numbers, but my intent is not to explain it to people who've never seen it before. My intent is to show some examples with numbers, so that if you are about to learn it, or if you recently have learned it with algebra, to help you sort of make connections between the numbers and the variables or the unknowns in your algebraic expressions. So if you're just about to learn this with algebra, then you can have these examples to think back on as you learn the algebra. Sorry about that. As you learn the algebra, you can think back on these number examples and think, oh yes, that makes sense. So in the two cases, we're going to have two different problems, and each of our stick people here are going to solve them different ways. And then we'll just look at sort of how these two ways are the same and how that generalizes. So in the first question, we have 5 friends, and they're going to some sort of event. It costs $100 a ticket, so it's a pretty fancy event. Maybe it's a playoff game or some sort of big show. And the friends, despite buying the expensive tickets already, have also decided they're really going to go all out, and they're each going to get $12 snacks as well. So as they're here at their event, one of the friends, the blue stick person on the top, is thinking, I wonder how much we paid for this all together, right? So what they're doing, they're going to think, okay, let's see how much each person paid. So, well, it was $100 for the ticket and $12 for the snacks. So the first thing I'll do in my head is I'll add those. And then once I've got them added, I'll multiply that by 5. I'm writing that out in front because it looks a little bit nicer. So what they do, that's 5 times 112, and that comes out to 560. So this person added first, oh my dear, sorry about that, and then multiplied by 5 afterwards. Now, the same person's friend down here has a slightly different technique. They say, well, first of all, I'll figure out what we paid for the tickets altogether. So there were 5 of us, and each ticket was $100. So for tickets, we paid 5 times $100. And then for the snacks, well, again, there are 5 of us, and the snacks were each $12. So we paid 5 times $12 for the snacks. So this is how they're thinking about it. And then they think, okay, 500. 5 times 100 is 500 for tickets. 5 times 12 is 60 for snacks. That's 560. Now, of course, both people get the same answer. And I think at least if you're in my target audience watching this video, you say, yeah, of course, I know how to do both of those methods, right? So whether you add first or whether you multiply each of the add-ins by 5, and then whether you add first and then multiply, or multiply by 5 and then add, you come out to the same answer. Let's look at another problem which looks quite different, but it's really getting exactly the same mathematical idea. So we have these two properties next to each other, and then they're rectangles, and they have the same sort of depth here. The first one is slightly bigger. My diagram isn't quite to scale here, but my first one is slightly bigger. It's 100 meters long and 40 meters wide. And the second one is just a little bit smaller. It's 80 meters long and 40 meters wide. Again, we have our two stick people friends who are wondering, what is the area, what's the total area of these two properties together? So, stick person number 1 thinks, well, first what I'm going to do is I'm just going to treat this like one big rectangle here. I'm going to do 100 plus 80. And then once I've got that figured out, I'll multiply it by 40. So we're treating this like one large rectangle, 100 plus 80 for the total length, and then the width is 40. So if they do that, they say, okay, well, that's 40 times 180, And then maybe, I don't know how they do this, maybe they do some long multiplication, maybe they pull out a calculator, maybe they have some mental math. But what they get is that this is 7,000, sorry about that, 7,200 square meters. So the area of the large rectangle is 7,200 square meters. Now, the other stick person friend here does a slightly different technique. They're going to find the area of this one, and then the area of that one, and then add. And of course we know they should come out to the same answer here. So this person is going to do 40 times 100. So that's the area of the left property. And then they're going to do 40 times 80. So as they do this, they think, okay, the area of the left property, 40 times 100, that's 4,000. And the area of the right property is 3,200, which altogether is 7,200 square meters. So as we look at our examples here, what I'm hoping that you see here is that, again, this is the same thing as we illustrated back here. If you'd like, you can add first and then multiply by 40, or you can multiply each of the add-ins by 40 and then add the total. So we'll write that a little bit more formally down here. If we had A times, for my yellow, I'm going to call that B, and my purple I'll call C. Oops, sorry about that. Lots of extra noises here. I hope they're not too distracting. That is the same as A times B plus A times C. So this is the distributive property of multiplication over addition. Now the title in brackets says and subtraction. I'm going to leave the subtraction for you to do as an exercise. So what I'd like you to think of, if you'd like to, is a similar situation here, but the people are not buying snacks. Instead they have a $20 discount. And you can think of a similar situation here, except you can look at only this property, and then you can imagine that for some reason they've removed a slight strip from the property. So it used to be 100 meters long, and now it's gone down to 99 meters long. So you can try to figure out the area of the remaining property. All right, thank you very much.